Welcome and thank you for joining us in digging deeper into V9 of the Australian curriculum years 7 to 10. Today we're going to focus on data acquisition and analysis. This presentation is one of a series. This is the 6th in the series, and you're welcome to go back and see the other presentations. They're available online. And this presentation is on data acquisition and analysis, that was you've already said, and there'll be one more in the series coming up called Designing and Assessing Digital Technologies Projects. We're your presenters. I'm Sarah Boyd. I'm a senior educator here at Grok, and I'm presenting with Caroline. She's a lead educator. And over the years, we have lived experience of the changes in curriculum and policy that flow through the education sector. My background is in software engineering, and in the last 6 or 7 years, I've been teaching 7 to 12 maths and senior computing, while Caroline has been a digital technologies teacher about the last 12 years, and we're both in the Sydney area. Caroline was also a head teacher, an ICT coordinator, and she coordinated ICT teacher PL. In today's session, it's a jam-packed schedule. We'll have a bit of a session overview. Then we're going to go through the 7 and 8 changes to the curriculum with version 9. We'll focus on spreadsheets and databases in year 7 and 8. Sorry, I meant 7 and 8 there. And then we'll focus on the learning experiences in year 7 and 8. Then we'll move on to the changes in the curriculum in years 9 and 10 in version 9, and focus a little bit on spreadsheets and databases in years 9 and 10, and then talk about some learning experiences relevant to years 9 and 10, and then a short wrap-up. The goals in this session are mainly to explore data acquisition and data analysis with the following emphasis: the differences between the curriculum 8.4 and 9, some learning experiences, and some examples where you could assess your students. The main focus will be on the data analysis section of it. So we just touch a bit about what data is, because that's the key focus of today. And if you look in the digital technologies curriculum, you'll see that data is important, as it's 3 out of the 9 digital technologies concepts. And the 3 concepts are data representation, which is how we represent data, the way it's communicated, stored, and manipulated. And that was in a previous presentation. Then data acquisition, which in version 8.4 was data collection. That's where we're acquiring or sourcing the data. And then we calculate values to create information from the data. For example, if we got data off a Fitbit or something, that's acquiring it, but then we have to sort of get it onto a machine readable format, like a comma separated file or something like that. Then data interpretation, the third one out of the data concepts, that's where we're extracting meaning from the data through the analysis. So you've got to analyze the data first before you can get the meaning out or find an interpretation. So focusing in on the curriculum, the main things we want you to know is how to access that curriculum content, and there are 3 key things. It's what you teach, how you teach it, and how you'll know your students have learnt it. The what you teach is the content descriptions. So they're explicit statements about what you need to teach the students. How you teach it, these are suggestions for how you teach it. They're not mandatory, and they're in the elaborations. So they are giving you guidance on what learning experiences you can create to teach those content descriptions. And then the assessment component is in the achievement standards. How will you know they've learnt it? So the achievement standard tells you what you need to assess. And it gives the way it works is we'd like you to provide multiple opportunities for the students to demonstrate success, including formative and summative opportunities. This diagram just gives you an idea of how the both of these content descriptions are assessed and taught across the range from 7 to 10. So you notice in year 7 and 8, that there is the word spreadsheets and databases in there, but the difference between 7 and 8 and 9 and 10 in data acquisition is that you're developing techniques in 9 and 10, and 7 to 8, you just acquire. You don't have to develop techniques. And in terms of data interpretation, it's just more subtle. It's a progression. You notice that you have to make predictions by identifying trends in year 7 and 8, and in 9 and 10, you have to identify outliers as well as trends. And we'll talk a bit more about the subtleties of this later. In terms of modeling and querying, in year 9 and 10, it's more sophisticated because you have entities involved rather than just attributes in year 7 and 8. So I thought we'd just mention here links to the general capabilities, digital literacy, because there's really a lot in the general capabilities about data. In this element investigating, there are 3 sub-elements that are related to data: locate information, acquire and collate data, and interpret data. So this sub-element supports students to understand how data can be generated and how we process data based on statistical understanding. So you can see they're recommending that you explore relevant data sets, read, manage, and process data from a variety of sources. And this is exactly what we are doing in the changes to V9 with analysing in spreadsheets and databases. If we have a look at the interpret data sub-element, that supports students to create and build knowledge by analysing and communicating its meanings to others. So you analyse the data and then you extract meaning from the data. And the way you do that is by looking at patterns and trends, and then use that to help solve problems and make decisions in various areas of the curriculum.
So now we're going to take you through the year 7 and 8 content descriptions and elaborations from the Australian Curriculum version 9. So the first thing we'll talk about is the changes in the content descriptions from the version 8.4 curriculum and the version 9 curriculum. The key things that have been changed, you'll see are highlighted in blue. So the version 9 content description here states that the students will need to learn how to acquire, store, and validate data from a range of sources using software, including spreadsheets and databases. Now, you'll notice here that what's changed is the validation element and the specificity of talking about spreadsheets and databases. And it's also important to note for the content descriptions, these are things that you actually have to teach the students, whereas we'll talk about the elaborations shortly, which are just some ideas on how these might be taught, that these are the things that you actually are required to teach. So you'll see these, the 8.4 curriculum descriptor has been broken down into a little bit more detail here. So the version 9 curriculum talks about analysing and visualising data using a range of software, including spreadsheets and databases, to draw conclusions and make predictions by identifying trends. So you can see here we're specifically being asked to talk about spreadsheets and databases. So we need to be very specific in what we're teaching the students in terms of those technologies. And it's taken that little bit further to actually draw conclusions. And we'll show you some methods of how to do that when we go through some of the learning activities shortly. Next, we've got model and query the attributes of objects and events using structured data. So this is added in that key term query, and we'll show you a little bit of how that can be taught using spreadsheets and not spreadsheets, through databases and SQL. So this section is about the version 9 elaborations. So just as a reminder, the elaborations are something that you are not required to teach. They're essentially examples of how you might teach these different content descriptions. And they're exceptionally useful to give you ideas in different methods of helping the students access this curriculum. So I'll go through them and I'll tell you which ones we're going to try and give you a bit further information on with our lesson examples. So acquiring data to answer questions for their own investigations for example, answering questions such as, does the canteen sell the right food? So students might design a survey to collect food preferences and data, accessing canteen sales data. So this is something that they're familiar with, and it's a helpful way for students to learn how to collect data. As I said before, this is simply an example, as are all of them, and these are just ways students can access this curriculum. So judging how meaningful data is to a question, its correctness, how up to date this data is. For example, does age affect the chance of cyclist injury? Are self-reported accidents reliable? Is the data before cycleways existed relevant? So this is helping students learn how to question the data, and this is a really important skill. Data shouldn't be taken at face value. They need to learn to question and be critical of what's in front of them. Storing acquired data using specialized and general software appropriate for how it will be accessed and manipulated. For example, a spreadsheet for visualization or a predefined database for filtering and queries. So these are specific software examples that can be used to teach students these skills. And this is an area we will focus quite a lot of some of our examples on. Lastly, acquiring, storing and validating data from a reputable source, such as the Australian Bureau of Statistics, to analyse the geographic distribution of First Nations Australians with the aim to highlight past and emerging trends. So this is just providing examples of how you can give students really valid and real world data sets. And we'll show you an example of how you can use those to make predictions and analyse some real world data to make connections for the students that might be relevant to them. All right, this is our next content descriptor and the elaborations related to this. Summarising data based on its attributes to identify trends and make predictions. For example, sorting crime data by type of offence, showing that burglaries have decreased over time to predict fewer burglaries will happen next year. So this is using some of the tools students might learn in spreadsheets. For example, they might create a graph and show how a trend line might demonstrate burglaries going up or down depending on certain data they have. And this is a way that students can visualize data using the software that they have been taught, be it spreadsheets, and then using that to make predictions. Another example is visualizing multidimensional data by choosing appropriate graphs. For example, a scatter plot of food prices and sales, colored by each food's sugar content, or diagrams such as a social network diagram and maps of crime rates by location to reveal trends, outliers, or other information. There's a lot of information in there, but essentially what it's saying is use visual tools to demonstrate key elements of data to help you read it better and have students interpret it to make predictions based on what they're looking at. This is our next content descriptor. Some of the elaborations for this one, modelling objects and events as structured data. That is the attributes relevant to the task, for example, products in the canteen and the sale of those products with attributes such as the product name, price, quantity, and nutritional value. These types of things can be done using spreadsheet software or database software, and we'll show you some examples of those. Using a spreadsheet table to model objects and events, including choosing appropriate formats for each column and filtering and sorting rows. And lastly, interpreting and querying single table databases using visual or simple SQL queries with a select, where, and order by clauses, for example, answering queries in a database for a historical event. So using SQL queries on a single table database is something we'll show you some examples for later in this session. So the third element in the curriculum that Sarah mentioned before, so we have our content descriptions, we have our elaborations, which I've just been through, and then last we have the the achievement standard. And this is how we determine if the students have actually learned the content. So we refer to the achievement standard to see what actually needs to be assessed. So the content descriptors are what needs to be taught, and the achievement standards are what we're actually assessing. So we want to provide students with multiple opportunities to demonstrate success, and we also should provide them with both formative and summative assessment options wherever possible. So this is the achievement standard for Year 7 and 8 digital technologies, and I've highlighted the relevant element here. So students acquire, interpret, and model data with spreadsheets. What's interesting here, you might notice, is that databases hasn't been mentioned. So students are required to be assessed in interpreting and modeling data with spreadsheets, but not databases. The idea is that they'll learn and build those skills in databases in Year 7 and 8 as a background skill and knowledge for when they learn it in Years 9 and 10. So at this stage, these are the elements that they would be assessed on in Year 7 and 8. So in this section, Sarah and I will go through a variety of different learning experiences. These have been specifically outlined for year 7 and 8. However, you'll find most of these will be relevant for years 9 and 10 as well. And the best thing to do is just to use your own judgment of your students and where they're at and differentiate accordingly. Now, I know from my personal experience, one of the most difficult things in teaching this type of content is finding useful data sets that students could not only relate to, but have some semblance of reality in the real world. So this here is an excellent list of real world data sets and data sets that have been created for educational purposes and set up with learning resources. So I strongly encourage you to have a look through these so that you can actually have a look and see which ones would be most relevant to your classes. We've also provided you some primary school examples. These are really useful for students who might find, I guess, the larger data sets a bit challenging. So in terms of differentiation, you might have a look at some of the primary school examples that might be more accessible for some students. This is just an example of one of those data sets, just so you can see what's actually available. So this is the CSIRO website, and they have a series of educational data sets. And the one that I'm indicating here is this mean sea level one. So if you go into that link, you'll find there's a teacher guide. And inside this teacher guide, it's a PDF that has a series of lesson ideas, questions that you might ask students. It also has a series of activity ideas and ways to interpret the data. So it's an incredibly useful resource. And it also gives you these 3 different options for the actual data itself, with a series of CSV files with data that students can use to complete the activities which are outlined in the teacher guide. This is all there ready for you to use in your classroom whenever you might like to.
So one of the first things you do when you sort these data sets is, if they're real data sets, they'll be messy. So they won't have every column filled in. Some of the values might be wrong. So you've got to teach the students that this is the real world and they can deal with that. And some of the things that can be wrong is there's things missing, empty or missing data. The values might be the wrong kind. So if you're measuring time, you'll see there's a negative number. The values might be out of range. For example, if you've got a percentage, you might get a 200%, which wouldn't make sense. Also, there might be some incorrect values that just couldn't be right. And you might have 2 rows with the same data, but not matching. So here's an example here that I got from the internet, which was some movie data. And you can see all the things in coloured highlights are problems. So in the first column, there's no director name for the Batman versus Superman movie, and it's got NA instead. Or the girl with the dragon tattoo, that's got a null director name. So maybe that person couldn't find the name for that, for example. And the duration, -50 in red in the third column, that's not correct either. And in the gross column, there's like an empty bit. And you've got weird characters happening in the movie title. So these are real things. So you have to teach the students. They have to make decisions about that. So cleaning the data might say, if I don't have a value, I'll make this decision, or go and remove all different characters, or make all the country names in capital letters, for example. So it's actually not as easy as it might seem when you get real data sets. With the cleaning data, we need some methods for how to do this, and there's ways that can help us just by looking. That's inspection. Some are really obvious. However, some of them are not so obvious, and we can use conditional formatting to do that, which Carolyn will talk about later. And that's just a way of using rules to format cells in particular colors so that values that are particularly different pop out to us. We can do things like use summary statistics. For example, if we did the average of a percentage column and we got an average that was greater than 100%, then we know there was a percentage that was wrong inside that column. And just visualizing can help us spot values that are really wrong. And the other thing that can happen is data sets can be hard to understand, like they might have unhelpful column names. So you actually might rename the column names to something that means something to you. So it's just to point out that when we're dealing with real data, that cleaning messy data is a large part of the project.
So one of the best things that you can do for students, not only for this topic, but is to teach them spreadsheets. They're a life skill. I've taught spreadsheets to students from grade 7 to 10, sometimes in year 11 and 12 as well. And what surprises me even still is how much they really enjoy it. And I think the reason is because they can see how useful it is in the real world, and they can also see how powerful it is and automate so many things. So it's a really, really valuable life skill as well as relevant to the curriculum. So what we're going to look at in these activities is using Excel in order to teach spreadsheets, but other spreadsheet activities, spreadsheet software you can use is things like Google Sheets and OpenOffice. They mostly have the same functions. Sometimes they'll operate in a slightly different way, but you should be able to use any of them to teach these concepts. So most of the knowledge and skills that you are required to teach in this part of the curriculum can be taught through spreadsheets. What's really useful is this tour option within Excel. It actually gives you a step-by-step process of how to use various essential tools. And this little video here is just how to find those tools. And you'll see here a variety of different examples that they go through. So there's things like add and fill. You'll see there's more advanced things like pivot tables, and you can go through these with your students. You could go through these things yourself. You could adapt your teaching based on them. You could use them to build learning resources. It's just a really useful way to see some of the core functionality of the software. And it also means you won't have to necessarily start from scratch with it as well. This slide just goes through some of the core skills that students should learn in year 7 and 8, even in year 9 and 10. They should learn what a spreadsheet is. Surprisingly, quite a number of students, especially in the early years of high school, don't actually know what a spreadsheet is. Once you break it down for them, it's fairly quick for them to pick up the basic skills. So just going through what rows, columns, and cells are, how to reference a cell. I find it really valuable as well to show a historical perspective of the spreadsheet to show students how it began. I originally showed this video from Dan Bricklin, the inventor of the spreadsheet, to year 12 as part of their curriculum, but I also have showed it to year 7 and 8, and it surprised me how fascinated the students were with it. They really found it useful, and they were excited by the old technology, but also it helped them realize just how revolutionary spreadsheets are and help them appreciate their power and what they can do for people. So I strongly recommend showing that video as a bit of a starter when you teach spreadsheets. Other things that students can learn is how to use formula, how to construct their own formula, but also how to use built-in functions, things like sum and average. They might like to learn things like transpose, fill, sort, filter, and definitely how to visualize data using things like conditional formatting graphs. And a lot of these things we'll go through. Some of them you'll find in the tutorials, and you'll be able to find various resources as well in a lot of different educational resources. This little website is quite good. What it does is it goes through a variety of different ways of visualizing numbers, and it asks you to determine which number is the most common. And it only gives you a short moment to actually figure out what the most common number is. And you'll see, I strongly recommend having a play with it, and you'll see quite quickly that it's indicating how hard it can be to interpret how many numbers there are depending how it's been represented. And I think this is a really useful hook for students to see, okay, how this is shown to me is really making a difference of how I can understand the data. So I definitely recommend using this as a hook activity, but also as a way to demonstrate data visualization tools and their importance in how they're represented. So one way to visualize data is to use graphs. So having students graph the data can help them interpret it, help them identify trends. We can I'll be showing you in one of the next slides how to add a trend line so students can identify patterns. There's a variety of different types of graphs, and you'll find a lot of these are available within the spreadsheet software. If you need to access some information about any of these types of graphs, if you haven't used them before, there's this website for CSIRO which goes through some details on what each of these different types of graphs are and what they're most useful for. So what I'm going through here is just some tools on how you can use conditional formatting to visually interpret data. So that formatting that was just added there was just conditional formatting, which shows color scales. So you can see the 0 is red and the higher numbers are green, and it's a gradient between those colors. And you can also add specific formatting to specific cells based on a variety of different things. What I'm doing here is adding in a color based on a precise value. So you can see all of the A's have been turned blue. And you can actually copy and paste the formatting. That's why I've done that there. So if you've applied formatting to one section of a spreadsheet, you can actually apply it to another section of the spreadsheet if you forgot to do so earlier. So using these color scales, and there's also data bars and creating rules, are just really good ways to demonstrate what data means. And you can also sort data once it's been formatted in a certain way. And that way you can see really clearly the different scales of the colors and the gradients and how they clearly represent the data and the values and the ranges of them. This is another example of visualizing data. This is an example from that CSIRO data set that I showed you earlier. And I'm going to go through how to create a graph to represent data patterns. And this can be used to do things like add trend lines and make predictions. So in Excel, you can easily add a variety of different graphs. And this is going through how to add a particular type of chart. There's a variety in there, and you can see there's heaps of different ones. But you also get recommended charts, and that's the one we're going to use here. So you can see all of the different data from the years, I think it was 1880 up to maybe 2009, I think, of the mean sea level globally. So that data is being represented here on a graph, and then we're going to add a trend line so you can see that data in a different way. So this is something you can do with any data set that you use and help students visualize that data. So on this particular example, this is using that same data set from the CSIRO website, and it has the global mean sea level here. And each of the years, you'll see there's a number representing that sea level. And what I'm doing is using a formatting rule to change the data that has gone down from the previous year to be red, and the data that has gone up from the previous year to be green. So you can see the patterns if the data is changing a lot in any particular year. This is a useful way to see how the data is changing over time. So all you have to do is go into the conditional formatting and use the greater than and less than rules, and you can change the formatting to however you want. But there's some predefined options that you can use within there.
So some other learning activities that we can use to teach this spreadsheet stuff is one from Grok. It's a Grok course. It's quite a new course, and it's called Data Analytics. And in this course, there's a module introducing data, really going from the basics. So it's aimed at the Year 7 students, what data is, how we use it in everyday lives. And in the second module, we introduce spreadsheets. And just as Carolyn was saying, some of the key things that you want students to learn about spreadsheets, they're covered in this course. So it's a nice way to introduce students to spreadsheets and data if they don't have much experience. And then in module 3, we talk about identifying errors in data and how we have to clean the data, and then communicating our findings to others. So we'll take a little bit more look at the some of the screens and the learning experiences in this course. So you can see here, it specifically explains what a spreadsheet is, which, as Caroline said, is really important for kids to know. Not all of them will know that. And then explaining the concept of data visualization. And it's got a series of multi-choice questions and different ways to teach the content. Then it actually goes right into the details of what a table is in a spreadsheet, what columns are, what rows are, what a cell is, and then it will ask questions about those to test the user's understanding. Now, once they've sort of acquired some of their spreadsheet skills, a really good way to test their learning is against the achievement standard, is projects. Data is really well set up for project learning. And there's a really good project we recommend developed by the Australian Data Science Institute, ADSEI, which is Linda McIver, who has done some work with Grok. And she actually helped Grok develop the data analytics course that I just told you about. In this project, which is called the Countries in Conservation Project, students analyse and interpret real data sets that Caroline was talking about. And in this case, they're related to the conservation areas in different countries. The students identify trends in conservation across different countries and make predictions within a country about what's going to happen. And it's really a cross-curricular project because it does address content descriptions in geography, maths, and digital technologies. And you'll see these content descriptions mapped. Although it's to the version 8.4 of the curriculum, you'll easily be able to see how these will map to the version 9 of the curriculum. And I'll do a deep dive into a bit more about this project in the next few slides. So again, we're using real data here, which is what we recommend. And you can see from this extract that it's not simple. It's got some weird names in there like terrestrial and naive. So you really have to, as a teacher, walk your students through the data and explain to them what's relevant and what they need to know. So in this case, actually in the project, they're really only looking at the percentage of conservation area covered in each country. So there's only really 2 columns that are of interest in this particular analysis. It's the country column, A or B, and then the value column, which is right down at column U. And really the rest of it is just explaining what the data means. That terrestrial means Earth, and there's a marine, which is the sea data. And we're just going to look at the terrestrial Earth-based data for this project. So in the steps that the students follow in this project, we get the students thinking about conservation around the world. That's the sort of other curriculum that's involved in this, geography and possibly history. Then we've got to analyze the data and clean it to make sense of it, because of course it's going to be messy because it's real. And then the students visualize the data and work out the best graph. So this is all in a lesson sequence that is identified for the teacher. You can follow along with it. I'm just summarizing it here to give you a flavor if you want to pursue this further. Then the students are encouraged to, in step 4, identify any unusual values and to formulate their own problem it's scaffolded in the sense that you've got this limited set of data, but they can choose a subset of countries to compare. So they're suggested to choose 3 different countries to compare, say. And then once they've chosen the 3 countries, they can look at the different conservation between the countries. Then they can choose in step 6, 1 country and view those changes for that country over time and make predictions. Because when we've got time-based data, that we can identify trends and make predictions. In step 7, thanks. This is just to give you an idea of cleaning the data. And I have used conditional formatting, which Caroline showed you how to do in the previous slides. And I just made a simple rule that said, if it's greater than 100%, please highlight it in red. And that's identified that I've got a problem with my data because that value is a percentage measure. I should not be able to have 125% of conservation areas in my country. So already I can see there's a problem with that data, and then we have to make a decision that probably we would take that out of our data set because the data is incorrect. So this is just the challenges of dealing with real data sets, and it just to show you how you use conditional formatting here. The next step, once we've cleaned the data and we've got the data that we need, is how to visualize the data to identify trends or compare between the countries. So the point here is that some graphs are better for certain situations. And in this case, the pie chart on the left, it's not really particularly helpful. It's a nice chart. It's got lots of nice colors there, but it's not helping us in our situation. If we want to compare different countries, the map chart on the right, that might be more useful if we wanted to see which countries that were closer to each other had more conservation areas. Or if you just wanted to know which countries, absolute values like 100%, you can quickly identify them from the bar chart in the middle. So it really depends what you're interested as into what graph you visualize, and you really want to teach the students to work out which graph is better for each situation. And just going back to the identifying trends for time-based data, this is one of the steps 6 and 7 in this project, is for them to choose a single country, and I've chosen Russia here. And then I fitted a trend line to that data. But what's interesting here is that if you had chopped this data off in 2000, and you'd made a prediction for the next year, you would have thought it would be going up. However, there's an interesting pattern here where after 2000, the data stays the same. So this is just to remind students as well that you can identify trends using a trend line, but when you make a prediction, it's only a prediction. And this proved us wrong. So obviously Russia just stopped conserving land in 2000. So that's quite interesting.
So this next section, I'm going to take you through how you can start teaching years 7 and 8 about databases and SQL. It's likely that they probably haven't learned anything about this before. So a good place to start is just to give them a bit of background information on what a query is and what a query language is. There's lots of great resources and videos out there that you can use that go through some of the basics. And some of those are on the Grok Academy website and the Khan Academy website, which I'll show you throughout this presentation as well. It's a good idea to break down with years 7 and 8 just some really simple information that they would understand, that when you write a query, it's really using natural language and how we think and speak. So what they're looking to do is tell the computer where the information that they want is from, what the information that they actually want from this location, and the names of anything specific that might be important. So for example, from the school's database, they want a list of students who take digital technologies, or they might want a list of students who take digital technologies and history. So it would give us the students who take both classes, or perhaps students that take digital technologies or history. So they might take one or the other or both. So we'll have a look at how some of these things can be constructed soon. This is a good example of a slide that you could even use for students. So clearly breaking down to students the elements of an SQL query. So students would need to construct a SQL statement that tells the computer that they want to select the name. So this is a selection of what the information that they want actually is from students. So this is the database or the table of student information where the subject equals DT or digital technologies, depending how it's saved. So there's 3 key elements that I would start addressing with the students. So select, from, and where. And then show them how that comes together in a syntactically correct SQL query. So you select the name from the student's table where the subject is equal to DT. So name is the field that we're looking for. Students is the table it's found in. And the extra element is the refinement of our query, so that we only get the specific information that we're looking for. So this is an example of how you can create a very simple query in SQL. And if you have a look on the Grok website, there's interactive tutorials and problems where they can actually test their skills and learn how to run some real queries. So this course is the Intro to Databases SQL course on the Grok Academy website. And I strongly recommend having a look through it because it goes through everything you really could need for year 7 and 8 to get a background understanding of how to use SQL and how to apply it to single table databases. This is just an example of one of the slides that's available on the SQL course on the Grok Academy website. This is just showing how you can do a very basic query on a table. So looking how to use the select statement and the from statement. So for example, the student will select the common name from the animal table. And these are interactive. This is just a screenshot, but on the website, you can click the play button and it will give you the results. And it breaks down exactly how to use these terms and what they're for, so students can start building that background understanding of how to construct queries. This is an example of one of the problems that exists on the Grok Academy course. So you would, it actually allows you to go through and type in a query based on this problem. So the problem states that the names of the fleets bringing convicts to Australia were named based on the dates that different ships arrived. All of the ships from the third fleet arrived in 1971. Show the first names and the surnames of all the convicts in our data who arrived in the third fleet. So the students need to say that they want to select the first name and the surname from the convict table where the arrival is 1971. And as you can see, all of the data for the first name and the surname is provided for you there. And if they were to write that query with the wrong information, you could actually show them how that would actually give them the wrong feedback. And you could see how the SQL query works if you don't actually put in that correct data. This is an example of that. So if you take away the surname and you run it again, you'll just get the first name back. So it's a good way to show the students how they can filter out the information that they specifically want to access. So in this instance, we've chosen to remove the first name, but if you select nothing, then you'll get nothing back. So you're selecting nothing, so the rest of the information doesn't matter. So I encourage you to get the students to play around with it so they can really see how these queries work.
And then we're going to move on to years 9 and 10, and we'll do a similar sequence. We'll have a discussion about the curriculum, and then we'll talk about some learning experiences. So the changes in years 9 and 10, we'll have a look at the content descriptions. So you can see that in PO1, that it specifically, like in year 7 and 8, mentions including spreadsheets and databases. So it's still developing techniques for acquiring, storing, and validating data, but now it specifically mentions spreadsheets and databases. And then once again, in these content descriptions here, this has been split into two to make it more easy to understand. And the modeling and querying entities is being split out from the analyzing and visualizing the data. And again, we've got the including spreadsheets and databases. And similar to year 7 and 8, it's now explicit that we're drawing conclusions and making predictions by identifying trends and outliers. In year 7 and 8, it mentioned trends, but it didn't mention outliers. So year 9 and 10 includes outliers, and then it also has querying entities and their relationships using structured data. So the querying is, again, specific, just like in year 7 and 8. With the elaborations, these, once again, are things that are optional. They're suggestions for how to teach the content descriptions, and they really give good ideas for how you should teach these things. But once again, they're not compulsory. So the first one is developing systems that store structured data, for example, a movie or travel review website that collects like-it scale ratings and written reviews. So that's one example. And could use a database for that more likely. Then the second elaboration is developing systems that check data is correct and meaningful using automated techniques and manual analysis. And this is where validation comes in here. It's checking that the data is correct. So you're validating movie review data. You've got rules to do that. Could be conditional formatting if it was a spreadsheet, or different in the database. And then user interface elements are important here, and detecting bias and fake reviews through simple statistical analysis. So that's sort of way more complicated than a year 7 and 8 example, and maybe that requires more than just a database. It might require a Python program. The third elaboration is developing systems that acquire, use, and protect data according to Australian privacy principles. For example, ensuring personally identified information is not publicly shared without consent and is protected from unauthorized access. So this ties in well with the privacy and security content descriptions. So these two more elaborations, again, we're mentioning data from the Australian Bureau of Statistics. And this is because we want students to access data from legitimate, real sources that are reliable, like government websites or Bureau of Statistics. Bureau of Meteorology is another good one. So we're encouraging students to use data from sources that are legitimate. And in this elaboration, they want you to access and store data from the Australian Bureau of Statistics in a format that's useful for analysis. For example, population growth across age groups in Australia. But also, you're encouraged to identify strengths and weaknesses of collecting data and to compare different methods. For example, online surveys versus face-to-face interviews, phone interviews, observation, comments in response to social media posting, phone logs, browser history, and online webcam systems. So this is really taking a bird's eye view of collection of the data and getting the students to critically think about the collection methods. Further elaborations are really about the making predictions by identifying trends and outliers. So the first elaboration here is summarizing data, its attributes, and the relationships between data sets. For example, about electorates and their demographics, historical swings and exceptions to predict an election outcome. So this is really moving into interpretation, data interpretation here. Then the next elaboration is developing interactive visualizations for exploring complex data. For example, population, life expectancy, and fertility rate. So again, these are global issues that they're encouraging the students to investigate and to use visualizations. And then the third elaboration here is using software to compare data to identify patterns, relationships, and trends. Again, an example of emerging trends in Australia's industries. So the focus in here is really on the software and systems in Year 9 and 10 versus Year 7 and 8, which is more relying on the spreadsheets. And the final elaboration, which is mentioning machine learning, which is really, we're not going to talk about that today because that's getting a bit more complicated, but that's something that you could pursue if your students were up to that. And then there's elaborations related to the modelling and the querying of entities. So this is more towards the database side of things here, where you're encouraged to model entities and processes, attributes, and the relationships between them. For example, creating database tables for a movie, a user, and a movie review. And notice that there's more than one table here because this is Year 9 and 10. Year 7 and 8, you were just looking at a single table. In Year 9 and 10, it's really about multiple tables and applying that to a real life application like a movie review system. And our second example is specifically about using a database and structured data for a particular problem of a student choice. And again, the third elaboration is really saying multi-table databases and using joins and group by clauses. And these are just more complicated database structures. So for Years 9 and 10, the achievement standard, remember, that is what you need to assess. That's where you want the students to reach by the end of Year 10. And you really want to provide students with multiple opportunities to demonstrate this achievement standard with both types of formative and summative assessment. So for Years 9 and 10, the achievement standard is really the first sentence summarizes what you need to achieve by the end of Year 10. So by the end of Year 10, students develop and modify innovative digital solutions, decompose real-world problems, and critically evaluate alternative solutions against stakeholder elicited user stories. And this is really in a summary of what you want by Year 10, but incorporated in that is that students need to acquire, interpret, and model complex data with databases. That's really the part that's related to what we're doing today, but the first sentence sort of summarizes what you want by the end of Year 10. So some learning experiences related to Year 9 and 10. So with the spreadsheets, really everything that's been covered in Year 7 and 8 can be used here. And it's really about what previous experiences students have. Some students may still have never seen spreadsheets in year 9 and 10, in which case you really have to start at that year 7 and 8 level. And these can all be built on with more advanced skills and projects, depending on the students. Some examples of what we recommend are cell referencing, absolute or relative, pivot tables. This is where you can slice and dice a spreadsheet with many columns. You can basically combine columns and rows and do all sorts of fancy stuff with pivot tables. There's plenty of tutorials around that you can see on that. You can do some what-if analysis. This is like sort of goal seeking. You can use an Excel tool to do that for you. And there's a special tool pack add-in you can get for Excel if you really want to do series statistics. Some more functions we suggest you look at are VLOOKUP, index and match, COUNTIF, SUMIF. And you'll find tutorials on all of those on the web. One thing we really recommend having a look at is the Gapminder website. The Gapminder website has motion charts, which are dynamic bubble charts. And that basically allows you to see how things change over time with multiple variables. It's a really fun website. And there's a guide, a PDF guide that can show you how to use the website. And we put a link for the website there. But you can see in this interactive here, each of those circles or bubbles represents a country. And that's the life expectancy for that country versus the income over time. And the time is showed in the background, and you can see how different countries change over time. And you can choose which countries that you want. You could maybe just look at 2 countries together, Australia versus, say, any other country, Afghanistan, and compare them. Or just look at Australia and see what Australia's doing over time. You can see here that Australia is changing very slowly. Its life expectancy, it's gradually getting higher around 1880. And yeah, it's just really a fascinating website to investigate many real world issues, which is again the focus of the elaborations. Encourage the students to focus on real world issues, and you can download the data for particular data sets too. Okay, one learning activity we recommend is, it's from Linda McIver, who is responsible for the Australian Data Science Institute. It's a project that she recommends. And the idea is to get students to use an existing data set to explore some global issue of interest. So it's got student choice involved, such as climate change, homelessness, world happiness. For example, here you could do the UN Sustainable Development Goals and choose one of those. And there's many other data projects that you could look at, but I'm going to focus on this one in this presentation. So Linda McIver calls it the Global Project, and that's a little picture of her book there, which is all about teaching kids data science, basically. So the steps in the project Linda recommends are here, and I'll dive into these to give you a flavour of how this might work in practice for your classroom. We recommend that you do it as a project or an assignment. Data is really well suited to that. So the steps involved are, first you source and make a copy of the data set. Remember, the students are going to choose a data set in a topic that interests them, and they can put into a database or a spreadsheet. We'll just sort of talk through a spreadsheet for now, but it could be a database. Then they have to really spend some time understanding the data set. That's step 2. What do the columns mean? What is the data that's being measured? How do you measure it? Everything like that that's related to that. Once they have the data, then they have to really drill deep into the data and see if there's any problems with the data set. Is it messy? I'm sure it will be, and they'll have to clean it and find out which data is meaningful and which data they may have to take out of their data set. Then the students are encouraged to explore the data set using their spreadsheet or their database skills. And that might be just looking through particular columns and seeing what the data is doing. Then Linda recommends once they've explored it, then they find a question the data set can answer. And then they go and answer that question, check it with a friend and communicate the answer. I'll just drill into these a bit more in the following slides. So step one is downloading the data set. So I've chosen an example here that a data set is the World Happiness Report data set, and you can find a link to that there. And then this is a little glimpse of what that happiness data set here. It's got all the different countries, and this is taken in the year 2017. And it has a lot of different columns, and I wouldn't expect you to know all of these, but we're just going to have a look at the one of the columns, which is the happiness index. So in this survey, people were surveyed from many different countries and basically asked how happy they were, and a lot of data was collected about them as well. And step two is to understand what all these fields mean. And there's you would go to the document for that, where the data set you found was. Usually, if it's a good data set, it will explain what all the columns mean. And there is one for this data set. The next step is to identify problems with the data set. And I've just put a little extract here. You can see already there's a missing data point in that extract. And there's too many decimal points here, making it hard to compare the different countries. It really doesn't make sense for these numbers to be compared with decimal points. So one thing you would do there is you would format the data to make them whole numbers, for example, or maybe with one decimal point. Step four would be to explore the data set. So you might want to graph certain columns against other columns. So in our example, we're interested in happiness against, we might be interested in the happiness index, how happy the person is on a rating of 1 to 10 against the GDP for that country, or the log GDP, which is just a different way to measure GDP for each country. And then they might find a question. So the question I came up with is happiness correlated to GDP? If you're happier, does the country have a better GDP? And then step 6 would be, once you've formulated your question, you want to answer the question. And a good thing to do is to graph the data to try and answer the question. So for me, if I wanted to see if happiness is correlated with GDP, I would try and graph happiness and GDP, identify a trend, and maybe we'll make a prediction. So here's an example that I've done, and I've just chose the countries starting with A and B, just to keep it simple. And the happiness index was plotted on the y-axis, and then the GDP across the x-axis. So you can see that in general, there is a trend. I fitted a trend line, and the more GDP, the higher the GDP, in general, the happier the country. However, there's an interesting outlier here for Botswana, which has got quite a low GDP, but still a quite high happiness index. So this is an outlier, an example of where you've identified an outlier that doesn't flow with the trend. So this project really can incorporate a lot of the curriculum content descriptions that we've described. And once you've made some sort of conclusions in this project, you encourage the students to check your answer by asking other students, their teachers, and check if their conclusions make sense. So in my case, if I concluded that the greater the GDP, the happier you are, I might go and Google that and see if that's confirmed by research. And then you'd encourage the students to present their findings in a report, communicate their answer. So this is the global project is a really good way for students to really test out all these skills that we've been teaching in this topic.
So this section here is a little bit more on SQL queries and how you can extend this for a Year 9 and 10 audience. Bearing in mind that if you haven't addressed SQL in Year 7 and 8, you really would need to address those basics before moving on to some of the more complex elements, because a lot of this is quite new to students. And when they first start addressing it, it can be a little hard to grasp the basics, especially if you're moving into some of the more complex elements first. However, if you've already done the basics, a quick brush up on them before moving into the more complex elements should be fine for Year 9 and 10. So you'll find on the Grok Academy course that we looked at before, it has some more complex queries that you can look at, for example, to incorporate some more complex conditions. So this slide here shows how to add an OR operator. So in this example, the destination needs to be Australia or New Zealand, and it will return those results. So you can see here that the destination is New Zealand or Australia, and you'll still get the results returned of both the origin and the destination. And on the next slide, we look at using the AND operator. So this is basically showing that both the query elements need to be true for the data to be printed into the results. So this is a Venn diagram showing and or on flags. So you can see if they're red, they're on this side. If they're green, they're on this side. However, if they're both, they're in the center. So an AND operator means that both conditions need to be true for data to be included in the result. So using this as an example is a good way to show students how this works. So you can find on this Grok course some examples of how to use the AND operator. So you can see here that you're looking for some data. So you're selecting status, classification, and common name from the species table. So this is still just a single table where the status is endangered and the classification is mammalia. So you can see here that we have that as the classification, and we've also got the endangered status. So both of these had to be true. There is more complex queries that you can start looking at. You could look at these in year 7 and 8. However, they do start building the skills more in depth. So I do recommend these types of things more for a year 9 and 10 audience. What you can see here is a query that is using the AND operator. So the student needs to find specific information, so year, origin, and refugees from the people table. But these things all need to be true. The origin is Iraq, the destination is Qatar, the year is greater than 2010, and the refugees is greater than 0. So all of those things have to be true in order for this to return true. And then last, we've got this new operator called order by, and we're ordering it by year. So you can see the results here ordered by year. So they go from 2011 up to 2014. So if you didn't have the order by year, it wouldn't give you those necessarily sequential in that particular order. So this is a useful operator that you can show students in ways to sort their data. So one of the things that the syllabus or the Australian curriculum recommends is for students to use multi-table queries. And this is a resource that's available on Grok Academy, which is an SQL course. So it goes through SQL basics and some more advanced SQL queries, which is the sort of thing that I've already gone through. However, there's also relational queries in SQL, and this involves going through showing students how to do queries across multiple tables. And it has inbuilt tutorials and descriptions of how the syntax works and interactive ways of using the code that will really help students build those skills. So the course has a variety of different activities inbuilt. There's challenges, there's videos to help build those skills as well. It also has examples of how to use different operators. So for example, this is showing how to join related tables using different methods. And there's videos on how to do that as well within the course. One of the things that's really good to know is that the concept of data and interpretation and the way that it is accessed in different areas of the curriculum really works well. And some of the things that we have gone through in this particular presentation and some of the skills that you'll learn in other subjects work well with data. And you might even look at doing some cross-faculty or different projects which incorporate multiple skills and multiple subjects to really show students how this can be applied to all walks of life, not just digital technologies. And these are just some examples of how these are incorporated into the curriculum in other subjects. We've given you a list of resources for further reading. So these are just some examples of things that could be useful to implement more things into your courses, or some different resources that might be more suited to your particular context. And there's more here on this slide as well. So we should be making these available for you. So you should be able to click on these links and access the different elements that we don't have the URLs for you. The next session that's coming up in this series is the Designing and Assessing Digital Technologies projects, and that will be the last one in this series. So in case you didn't know, the Grok Academy platform is now free for every Australian student and teacher. So if you haven't already signed up, I strongly recommend you do. It's Grok's mission to educate all learners in transformative computing skills, knowledge, and dispositions. The partnership with WiseTech removes the financial barrier to schools in using our resources, as well as allowing us to expand our team to continue support schools, teachers, and learners. So the fact that this is freely available now means you won't have that barrier, and you'll be able to use this across all classes from K to 12. And if you do want to contact us for any reason, these are some methods of doing so. And thank you for your time.
Thank you.